Okay, we just introduced a 2 by 2 matrix determinant. This kind of goes with the next piece that we're talking about now is 2 by 2 inverses. Please go ahead and write down this box right in here, all of that. And then we're going to try an example together. So to find the inverse of a 2 by 2 matrix, we're going to use this piece right in here. So how you would note an inverse is a to the negative 1 power, so that represents inverse. So you can either write it like this, which this represents determinant, or like that. So I'm going to go ahead and just erase this. This is getting kind of messy for me too. We're going to just stick with this side of the equation. If you notice this denominator here of AD minus BC, that was your determinant in your 2 by 2 matrix. So you probably remember that now, AD minus CB, where you take AD minus CB when you multiply those together. Okay, so we're going to find the inverse of this 2 by 2 matrix. We have matrix A, which is 3, 1, 4, 2, and we want to find its inverse. So we say the inverse equals 1 over, and now we're going to take A times D, so 3 times 2, and then C times B, that's your determinant in the denominator there. Alright, now some things are going to happen within this matrix. These two numbers are going to flip-flop. So this becomes now a 2, and this now becomes a 3. And now these two numbers negate themselves. They change signs. This becomes a negative 1, this becomes a negative 4. Now let's just go ahead and simplify this fraction. So the inverse of A, 1 over 3 times 2, that's 6, minus 4 times 1, which is 4, so 6 minus 4 is 2. Then we have 2, negative 1, negative 4, 3. What this represents out here is a scalar multiplication. So what we can do is we can multiply all of the elements by 1/2. So you would take 1/2 times 2. So 1/2 times 2 is 1. Then you take 1/2 times negative 1, which is negative 1/2. And then 1/2 times negative 4 is negative 2. And then 1/2 times 3 is 3/2. So our new matrix, that's our inverse of A, is below. Now, here's a question for you. How can you prove that your answer is the inverse? If you multiply A times A inverse, you're going to get what we call the identity matrix. So it'll be 1, 0, 0, 1.